All right, so make sure that you have downloaded and printed this out, or you have it on a PDF on some type of mobile device or something like that where you can look through it. Or if you have to go old school, then by all means, just have it on a computer and get your paper and pencil out and just work through the problems as is. That's how you'll be uploading these assignments. So as always, again, we have the state standards at the top, standards-based objectives here. I did number these pages. Give you a quick part through the introduction and things. So if we take a look here, if it starts with H, then it is an acid. We know HCl as hydrochloric acid, so it's definitely an acid. If you see an OH, then it is a base. So NaOH is sodium hydroxide. Those are the basic ways. Acids increase the hydrogen ion concentration, and bases increase the hydroxide ion concentration, or would take out the H plus concentration by pulling the H plus out. So this is a list of strong acids. This means that they have 100% ionization. So if you recall, we talked about how things dissociate. So 100% ionization means that if you have 1 molar HCl, that means you get 1 mole per liter of H plus ions, and 1 mole of the Cl negative per liter, but we're not as worried about that because when you're dealing with an acid, all you're worried about is the H plus being added. So that's what strong acids do. Here's a list of the 6 strong acids. Notice that the 5 that are monoprotic, that means they have 1 H, and there is 1 that is diprotic, that means it has 2 H's. If it were triprotic, that would mean it would have 3 H's. For example, phosphoric acid. This is a weak acid though. That's why it's not in the list above. So if we take a look here, same thing. We have 6 strong bases. Here they are. Now also you can see that most of them are monobasic, meaning they only have 1 OH, except for calcium, which is dibasic. And tribasic would be like aluminum hydroxide or something like that. But again, they're strong, which means that if you have 1 molar NaOH, that means 1 molar OH negative, 1 mole per liter of OH negative particles will be out there. So quickly, the properties again, if you watched the PowerPoint, very easy. These are the properties of acid, properties of base. This is often feels smooth or slippery. Well, that's going to be a base because it's slippery on the skin, where versus an acid would feel watery. Conducts electricity in solution is the last one down here. Well, guess what? Both of them produce ions. Both of them are ionic compounds. So that's going to be both. If you get either of these in a wound, yeah, you better believe that that's going to sting. Same thing if you get either in your eye, that would sting as well. So let's take a look at the naming of acids and bases. So acids is the most difficult. So you have to look at the end of what you would normally think of as the chemical name. So HCN, we know CN is the polyatomic ion cyanide. HBr, we know that Br is bromide. So you look at the end, normally we'd say hydrogen cyanide or hydrogen bromide, but the fact that they're dissolved in water, they're aqueous, this means that they are acids because they're introducing the H plus from here and here. So if you see IDE as the ending, immediately you know hydro is coming on the front. The other thing that helps you out with this is you don't see any oxygen here, and that's what makes it a hydroacid as well. So IDE, no oxygen. That means hydro goes in front and ic goes at the end of the stem. Well, cyanide, cyan is the stem, so it becomes hydro in front, hydrocyan, and we end the ending with ic, hydrocyanic. HBr, bromide becomes brome, hydro, brome, ic. Easy enough. If you see the hydro at the beginning, you know there's no O there. So if you're going opposite, hydrochloric, well, chlor is the stem. Since it's hydro, it's chloride. We find chloride on the front of the periodic table, chlorine. It has a -1 charge. So how many H's do we need to balance out a -1 charge? Well, each H has a +1 charge. So it's 1. 8, if the ending is 8, for example, nitrate, sulfate, chlorate, perchlorate, phosphate, then all you do is you take the root and you change the ending to IC. So chlorate, ClO3, chlorate, we take off the 8, we change it to chlor-ic. Sulfate, we do a little more adjustment here, but sulfate becomes sulfuric acid. Sulfuric. So here we take a look, opposite, perchloric acid. Well, we need to know what perchlorate is. Look at the back of a periodic table. We'll see that perchlorate is ClO4, and it has a -1 charge. How do we balance out a -1 charge? Well, H is +1. Same thing here. We have sulfuric acid. That is sulfate, which is SO4. That has a -2 charge. How many H's do we need to balance out a -2 charge? 2. Next, we have ite, sulfite, nitrite, hypochlorite, chlorite, phosphite. All of those ITE endings, that means that we are doing the us for the acid. So chlorite, we drop the ite and we change the ending to an us. That's different than chlorate because the actual structure is different. Here we have 2 O's, here we have 3 O's. You need that back of your periodic table or that list of polyatomic ions to go through that. So, let's take a look if we have any down here. Nitrous acid. So nitrous acid means we have dealing with nitrite. Nitrite is NO2 with a -1 charge. That -1 needs to be balanced out. It only takes 1 H to do that. Good, good. Practice through these for Tuesday. Let's do the bases. Well, bases, we've been naming bases forever. We just didn't know there were bases maybe. So you name bases as normal. NaOH, Na is sodium, OH is hydroxide, sodium hydroxide. Easy enough. The charge is +1 and -1, so that cancels out. Ammonium hydroxide. Well, ammonium, we need to look at the back of the periodic table, and we will find that is NH4. That has a +1 charge. So hydroxide, again, on the back of the periodic table is OH, and that has a -1. So Na4OH, 1 to 1, cancel them out. Remember, we don't leave the charges next to them, so it's done. How about calcium hydroxide? Well, calcium we know is Ca. Hydroxide is OH. The problem here is calcium has a +2 charge and hydroxide has a -1 charge. Least common multiple of 2 and 1 is 2. 2 divided by 2 is 1 calcium. 2 divided by 1 is 2 hydroxides. But we would never leave it like that. So we need to make sure that we put the brackets around because we need 2 hydroxides, not just 2 H's. Last one, lead-4 hydroxide. We know lead is Pb, and we know hydroxide is OH. Remember, this IV is 4. That tells us the charge of lead is +4. The charge of hydroxide doesn't change. It's still -1. So that means we have 4 and 1. Least common multiple is 4. 4 divided by 4 is 1 lead. And 4 divided by 1 is 4 hydroxides. Yeah, that's it. Keep in mind, let's say we had COOH3, right? This CO is cobalt. Is cobalt in group 1A, 2A, silver, zinc, or aluminum? No. So we need a Roman numeral there. OH is again hydroxide. So we need cobalt, Roman numeral, hydroxide. So what is the charge of the cobalt? Well, we know the charge of the hydroxide is -1. We know we have 3 of these for a total of -3. We have 1 cobalt. How can this cobalt counteract a -3 charge? By having a charge of 3. So cobalt 3 hydroxide. So there you go. I think that should be enough to get you down to here, page 3 and 4. Snap a picture or upload the file. Again, if you have to do this on blank paper, that's fine as well. All I need are the answers. Thank you, and this is our last unit for the year. So if you are trying to improve your grade, make sure you do finish strong. Thank you, and enjoy the week.